Hello everybody. Today we are going to deal with some two-step equations. So we've done everything every type of equation so far that is one step. We've done multiplication equations, division equations, addition, subtraction equations. We even did some square root and square equations. So anytime there's one thing being done to our variable, we've learned how to undo it. The question now is, what if there's more than one thing? And I said two-step, but we're going to actually some that are even more than two. What if there's more than one thing being done to our variable? What if it's being multiplied by something and we're adding something, for instance, or divided and subtracted? Okay. The order in which we undo those things matters, just like the order in which we do our normal operations matters. Okay, remember we talked about PEMDAS a little bit. So I got a couple reminders before we get into it, because these are things that are going to come up today. One of the things we're going to have to do today is when there's more than one thing happening, we're going to sometimes have to simplify. If you remember what we did with simplifying, there was two things. Sometimes we had to do one, sometimes we had to do the other, sometimes we had to do both. But when you're simplifying an expression, what that means is you get rid of any parentheses using distributive property. Okay, so in this case, if I have parentheses and something being multiplied, I can get rid of these parentheses by multiplying. Okay. Remember, I'm going to think of this minus as plus -7. And then I would just distribute the 2 to each part inside the parentheses. So 2 times 3x is 6x. 2 times -7 is -14. So I'm going to put -14. Okay, so we may have to do some distributing. We may also need to do some combining of like terms. Remember, like terms are terms that have the same variable. Okay, so if I look here, 3x and -7x are like terms. Okay, so if I combine those, 3x plus -7x, I add the coefficients. 3 plus -7 is -4. So those become a -4x when I put them together. Okay, the y's are also 2y and 2y. Those are also like terms. So if I add those together, those are both being added. So 2 plus 2 is 4. So I get 4y. And lastly, the numbers. Numbers are also like terms. These are the constants here. So I have 10 and -3. If I add those together, I get 7. So this would simplify to -4x plus 4y plus 7. Okay, I went kind of fast, but we've done that before, so hopefully you remember how to do that. All right, so we're going to talk about the steps for solving a two-step equation. And I'm going to give you an example, but first I'm going to ask you a question that might sound a little weird. The question I'm going to ask you is, how would you feel if your name was MEP? M-E-P, MEP. Would you be happy about that name, or would you be sad? Because I know one person named MEP, and he's not happy about it. MEP is sad. Okay, but fortunately, sad MEP can help us remember how to solve two-step equations. Because when we're doing this, when we're solving an equation that's more than one step, we need to be undoing order of operations. Okay, so because we do things in the order of PEMDAS, we undo them in the order of sad MEP. Okay, so we're just going backwards. All right. So sad MEP is going to help us remember how to, what order to do things in. The idea is we're figuring out the order we would have done them, and then we're undoing them by going in the reverse order. Okay, so let's look at an example. 4 less than twice a number is 12. Okay, if I were to write that equation, we have a number, some number I don't know. Let's call it x. Okay, and if I want to write 4 less than twice a number, we'll deal more with how to write these in a few days. But twice a number would be 2x. 4 less than that would be -4. Let's say that's equal to 12. Okay, so here's my expression. I'm multiplying this x by 2, and I'm also subtracting 4. So it matters which order I undo those in. Okay, so if you think about SADMAP, if we knew what x was, we would multiply by 2 first, and then subtract 4, because multiplication comes first in PEMDAS. Okay, so when I'm undoing it, I want to kind of walk backwards. So I had multiplied by 2 and subtracted 4. To undo that last step, I'm going to add 4. Okay, and that'll tell me what I had before I did the subtracting 4 step. Okay, so when it was just 2x, I had 16. Okay, and now I'm going to undo the multiplying by 2. Okay, which was the first thing I did. It's the last thing I undo. I get x equals 8. Okay, so if I know I end up at 12, adding the 4 back on undoes that minus 4 to give me 16, and then dividing it in half undoes the doubling it. Okay, and it matters because if we had done it in a different order, let's take that same equation. Let's say we thought we needed to divide by 2 first. If I divided by 2 first, I get x minus 4 equals 6. And then I'd have to add 4. I get x equals 10. All right, that doesn't work. Okay, not this. Yes. All right, so here's what those steps then look like. Whenever it's multiplying, dividing, and adding, subtracting, because adding, subtracting happens later in PEMDAS, it happens earlier when we're undoing. So we're going to start by simplifying if there's any simplifying to do. We're going to do our train tracks as always. We're going to undo the constant. Remember that's number without the variable, because this is the thing that's being added or subtracted. We undo that first. Then we undo the variable. This should say coefficient. Undo the coefficient. All right, that's the number being multiplied by the variable, or possibly divided. Remember, it's multiplication and division are basically the same thing. Okay, then we solve, and then we can check. Okay, so make sure you get these down in your notes before we go on. And let's practice it. So first I'm going to start by simplifying. When I'm simplifying, I'm looking to see if there's any parentheses I need to get rid of or like terms to combine. Okay, and there isn't in this case. You might be thinking like negative 9 and 36 would be like terms. Well, they are, but they're not on the same side right now. So we can't combine them right now. They're on different sides. All right, so no simplifying to do. Train tracks are drawn. Undo the constant. So this minus 9, this part that does not have the variable, that's the first thing I'm going to undo. So I undo minus 9 with the plus 9. Okay. So the minus 9 and plus 9 cancels out. That'll leave just negative 5x equals, when I add these together, 36 plus 9 is 45. Okay. Now I can undo the coefficient, the number with the variable, dividing by negative 5 to get x by itself. I get 45 divided by 5 is 9. Positive divided by negative is negative. So I get negative 9. Now, when it tells you to check, what check means, again, is that you're going to take this and plug it back in for the variable. So when you're checking, you do negative 5 times negative 9 minus 9. And I want to make sure I get 36 out of this. So negative 5 times negative 9 is 45. 45 minus 9 is 36. That's how I would check that. All right, let's do another one. 4x plus 7 equals negative 21. I don't have any simplifying to do. No like terms, no parentheses. So I do my train tracks. Okay, 4x plus 7. If I knew what x was, I would multiply, then add. So going backwards, I subtract and then divide. Right, so I undo the adding, and then I undo the multiplying. So subtract 7 from both sides. 4x equals, remember, negative 21 minus 7 is the same as Negative 21 plus negative 7. We still want to be turning our subtracting into adding the opposite. A negative plus a negative is a bigger negative. So I get negative 28. Okay, now to get rid of the 4, it's being multiplied, so I divide. I get x equals a negative divided by a positive is negative. 28 divided by 4 is 7. So I get negative 7. Okay, to check that, I'm not just doing this again. Checking it, I'm going to plug it in. 4 times negative 7, just replacing the x with the negative 7. This is why we learned how to evaluate expressions. I want to make sure I get negative 21. So 4 times negative 7 is negative 28. Negative 28 plus 7. But remember with the rules, a negative plus a positive is negative because the negative is bigger. And how much bigger is it? Well, if I subtract them, 28 minus 7 is 21. So it's negative 21. All right, so here's the first one where we have a little bit of simplifying we need to do. Okay, if we're going to get x by itself, we need there to only be one x. Right? I need to have it in one place. So if I have a 2x and a 3x, I can start by simplifying and combining those to make it 5x. 5x plus 7 equals 37. Okay, so I just combined these two like terms to get this. Okay, from there on, it's the same thing I was doing before. Get rid of the constant, the minus 7. 5x equals 30. Divide both sides by 5. Get x equals 6. Okay. To check it, I got to plug it in. So 2 times 6, I'm just replacing x with a 6. Every time I see it, plus 3 times 6. I got to make sure this equals 37. If I check it, 2 times 6 is 12. 3 times 6 is 18. If I add all those together, 12 plus 7 is 19, plus 18 is 37. It works. Okay, so 6 is the correct answer. All right, last one we're going to do. 3 times 3 plus x equals 27. So again, I have some simplifying to do. Here, the simplifying I have to do is by distributing. So I have parentheses. I'm going to get rid of them. 3 times 3 is 9. 3 times x is 3x. Okay. It's going to be possible we might have distributing and combining to do. We didn't in this case. We just had distributing on this one, combined on the last one. But those might both happen the same problem. That's possible. Okay, but I've simplified as much as I can. No like terms, no parentheses. Do my train tracks. Get rid of the constant. It doesn't matter that you have the constant, then the x term, and adding the order doesn't matter. So I'm going to get rid of the 9 by subtracting 9. Always got to do it to both sides. I get 3x equals 18. Okay, now I got to get rid of the 3 by dividing by 3. I get x equals 6. Okay, so that's my answer. I'm going to check it just by going back to my original equation, replacing the x with a 6. So 3 times 3 plus 6. And I want to make sure that does equal 27. So order of operations tells me to add first. 3 plus 6 is 9. Okay, 9 times 3 is 27. So that works. All right. Good luck.